So the lesson that we covered today looked at, you got an issue, we're using this symbol again, theta. Remember, that's theta. Theta is just an algebraic representation, so we'll write it up here again. Let's see if you can see it. I'll move the paper down a little bit. That's theta. And theta is just a way to represent the measure of an angle in degrees, okay? It's just an angular variable. It's an angle variable. That's all it is, okay? So when we get into radians, you'll have x. X represents radians. So we're gonna do theta, which is degrees. So let's look at this. It says for problems 1 through 8, not only are you gonna find the missing angle measures, you use inverse trig functions, okay, and round the answers to the nearest tenth. Okay, find the missing values. Okay, so first of all, what we're going to do is look at again what functions, and this is just, I'm going to do a couple of these using theta. So this is theta. This angle A is theta. Y'all see that? Good, because I know you can't answer me anyway. So angle A is theta. If the angle A is your angle, this is your adjacent. This is your hypotenuse, and this is your opposite. So the question is, which function are we going to use? Well, what do we have? We have adjacent and hypotenuse. Which function is that? Well, remember, SOHCAHTOA. And if I look at adjacent and hypotenuse, that's cosine. Okay, let me move this down just a hair. All right, so you got theta, and that's cosine. Okay, so when I'm looking at solving this, I'm going to use inverse cosine. I know that the cosine of theta, and you can also say the cosine of A. It does not matter. Either or, as long as I know which angle you're talking about. The best way to do it would be to say cosine of A, because what if you're trying to find two different angles in the same triangle, and they're both a theta of some sort? This is the best way to do it. So I'm going to actually just call it cosine of A. Cosine of A, which is theta, is equal to adjacent, which is 12, over hypotenuse, which is 13. Now remember, I want to get rid of the functions on the one side. I want to get A isolated. So remember, we undo the functions by taking the inverse. So I'm going to inverse both sides. That's not to the negative first power. That means inverse. The inverse undoes the original function. So I end up with A equals the inverse cosine of 12 over 13. And basically what this is saying is, what's the measure of the angle if the adjacent to hypotenuse is 12 over 13? So we're going to go into the calculator again. You're going to hit second cosine, which is your arc cosine, your inverse. And then you do 12 divided by 13. And you get 22, it says round to the nearest tenth, you get 22.6. So A is 22.6 degrees. Okay? And again, I just wanted to show you one example, or a couple of examples using theta. Let's do one more, and let me pick a different function. So that's cosine, and let's see here. There's a lot of tangents here and a lot of cosines. I'm trying to find one that's sine and I don't see one. So we can go ahead and do one of the tangent ones. So let's do number 2. Number 2, this is theta. Okay, this is A. That means this is adjacent. This is opposite. And this is hypotenuse. Because remember, hypotenuse is always across from the right angle. So what we're going to do is, which one are we going to use? Well, I'm given adjacent and opposite. Well, if you're SOHCAHTOA, that's tangent. So I'm going to use the inverse tangent function here. So the tangent of A, which is your angle, is equal to your opposite over adjacent. So angle A creates an opposite over adjacent ratio of 4 to 13. Well, I want to get rid of that and solve for A. So in order to get to the A, the angle, I have to undo this. So I'm going to inverse both sides. Tangent -1, tangent -1. The inverse will undo itself. You end up with just a, and then you have tangent -1, which is inverse, the inverse tangent of 4/13. So when you enter that into the calculator, you're going to hit second tangent, which is arctangent, and you're going to have 4 divided by 13. Remember, you got to be in degree mode, and you get 17.1. So you get 17.1 degrees. So that's how you use the inverse trig functions another way, but using theta as your angle representation.